All right, so interceptors. Multitude of foreign items are placed either intentionally or inadvertently into a drain or sewer system every day. Those items which are considered dangerous, flammable, explosive, toxic, poisonous, radioactive, or hazardous must by law be kept out of the municipal system. So there's certain things that they don't want running through our sewer drain. I mean, even though it is all contaminated, the things that already run through our sewer, they do not want certain things in the system, in the sewer system. That's because the way everything needs to be treated when it's taken away to to our sewer plants. So waste which is considered objectable, however, may be permitted to enter drain or sewer systems, but must be removed from the system before it reaches the wastewater treatment plant, or in some cases in the municipal sewer system. The device placed within the sewer system designed to remove the objectable waste is called an interceptor. Greased oil and sand are the most frequently collected objectable waste in the sewer system. Hair, lint, glass, and chemicals are also found frequently in commercial applications and must be removed from the sewer systems too. Many laymen refer to interceptors as traps. I mean, how many times have we heard about a grease trap? So grease trap interceptor does trap grease. However, the primary intent of the device is not to trap the waste, but the intent to remove the waste from the normal flow of the drain or sewer system. The term trap is most often used when technicians refer to P-traps. The main purpose of a P-trap is to provide a liquid seal to prevent the gases generated in the DWV system from entering the premises of the building. The liquid seal in the trap keeps the gases away from the interior of the building in order to prevent illness or a possible explosion. The vent system allows gases to safely vacate the area through the stack. Grease interceptors are required in commercial areas where food is handled and prepared. Kitchens and restaurants, they are not required in residents. But it is a good idea not to allow grease to enter the drain or stoppages will occur. Oil interceptors are found in parking garages, gasoline stations, and other commercial facilities which handle oil and petroleum products. Sand interceptors are found in car washes, parking garages, and areas where sand may be generated and may work its way into the sewer system. Glass interceptors are found in bottling plants. Hair interceptors found in beauty salons. Lint interceptors are found in laundromats, industrial plants, and hospitals also have interceptors which collect and neutralize chemicals. So there's all types of different kinds of interceptors there. You know, we mostly deal with the grease interceptor, but we have ran into oil interceptors here. I haven't ran into a sand interceptor or a glass or hair interceptors here yet, but we do deal with a lot of grease traps and oil traps here. That, you know, when we do work at any kind of auto shop, there is an oil trap. I mean, we do deal with a lot of car washes also. I mean, I haven't dealt with a sand trap there yet, but I'm sure they're all required to have them here. So keep in mind the primary objective of an interceptor is to remove objectable waste from the drain system and sewer from the drain and sewer system. Objectable waste does not belong in either the sanitary or the storm sewer. Once the wastewater has been removed from the system, it can be disposed of in a proper manner. The design of the interceptor is regulated by the local authorities. The model plumbing codes provide guidance. A professional engineer should also be involved in the design of an interceptor. Most designs do require the interceptor to be watertight, of heavy construction, and resistance to corrosion or decay. Specific materials such as concrete, steel, and cast iron are used in this construction. As mentioned earlier in the book, most interceptors function on one or more of the three basic principles: flotation, settlement, and neutralization. Keep in mind, however, the interceptors, for example, hair lint, may work by a screening process. Interceptors designed to work on the principle of flotation work with objectable waste which floats. Grease is such a waste. Grease is composed of fats, fatty acids, waxes, calcium, and magnesium, and soaps. It is a liquid when warm, but solidifies when it's allowed to cool. So it is lighter than water and floats when solidified. The design of a grease interceptor must allow it to collect grease and separate it from the waste stream. Grease interceptors are designed to drain from the bottom of the tank or to be chambered so the grease which floats will not be permitted to escape from the bottom of the interceptor. So here we have two different types of boxes. So this one at the top is what we're normally dealing with. Let me get you guys can see my mouse here. So this is the entrance. I mean, it's pretty similar to like our septic system that we were talking about earlier, except this is like, you know, having a big P trap at the end of your line. So your water would enter here. And it does the same thing where it separates the grease from the water. So because the grease is lighter than water, it's gonna float to the top. So the only way for the water to escape the trap is they have the opening down here where, you know, grease should not get, you know, is not going to be able to sink down and, you know, rise back up. So they have it here separated to where the water can get out through the baffle T here. So that's one way there in this case of how they use this grease trap. This grease trap here. So this, just imagine this grease trap cut straight in half. These are walls right here in the trap. So each wall in these traps are there to you know, to make sure that the grease does not pass through into the sewer system, which is the exit here. So just looking at this grease traps, you know, everything floats. That's why the wall is on the bottom. Oil traps that you find in auto shops, same deal. They use this type of trap. Sand traps, you know, because it's heavy, it's pretty much reverse. The settlement goes to the bottom and water passes over the top. And for the hair and lint stuff, I guess they have a screening process it goes through before entering the system. So an interceptor which works on the principle of sediment and is a sand interceptor. So we just talked about this. So sand is heavier than water. However, once sand is mixed with water and put in motion, it will remain in motion until it's allowed to slow or stop. Once the movement of sand in the water is stopped by the interceptor, the sand will settle. Septic tanks is similar to an interceptor in some ways. A septic tank works on principles of sediment. When the sludge settles to the bottom, septic tank works on the principle of flotation. When the oils and soaps float on the top of the tank, baffles keep the oils and soaps from exiting the tank. An interceptor which works on the principle of sedimentation usually drains from the top. Like all interceptors, regular plumbing is extremely important because the interceptor is full. It may overflow and blockages downstream may occur. The third principle on which an interceptor operates is neutralization. Manufacturing plants oftentimes deal with the interceptors which neutralize industrial chemicals. Chemicals and neutralizing agents are put in contact with and neutralization takes place. Most industrial chemicals are not permitted in municipal sewer systems. Some chemicals will kill bacteria, critical to the functioning of the system. Petroleum products may not be put into the sewer system. Waste which may be harmful to surface or subsurface water may not be discharged into the sewer system. Environmental laws are very strict. The interceptor most frequently encountered by a drain and sewer cleaner is the grease interceptor. There are two basic categories of grease interceptors: inside grease interceptor and an outside grease interceptor. Small kitchens and restaurants will generate small amounts small amounts of grease have inside interceptors. The interceptors may be in the floor mounted or installed above the floor. Larger kitchens and restaurants which generate large quantities of grease have outside grease interceptors. They are in the ground and made of heavy construction. Local health departments and plumbing commissions establish the criteria for sizing grease interceptors. The seating capacity of a restaurant or the number of meals that are served per day are a significant factor which determine grease interceptor size. A grease interceptor should be located as close to the grease producing fixture as feasible. It is not, however, to be located in the immediate area where food is prepared. If the interceptor is located too far from the fixture, the grease may cool and solidify in the pipe before it reaches the interceptor. The interceptor must be easily accessible for cleaning and inspection. And the grease must be removed on a regular basis. Again, failure to clean the interceptor regularly defeats the purpose of having an interceptor. A preventative maintenance contract calling for regular cleaning is the most efficient program. There are two keys to the grease interceptor functioning in the most efficient manner. The keys are the detention period of the grease and the flow through period of the wastewater. The detention period is the amount of time the water and grease is held in the interceptor. The flow through period is the time taken from the water to flow through the interceptor. The grease must be detained long enough to cool and permit solidification. The grease interceptor must not allow the influent to pass quickly along the bottom of the tank. A rapid passage of grease and water through an interceptor is called short circuiting. Short circuiting will keep the maximum grease from being retained, allowing some of it to pass through the system. Turbulence is to be avoided in a grease interceptor for it to function properly. The length, depth, and width of the tank area are key design factors to prevent turbulence. Flow control devices are installed in grease interceptors to help the detention period and to control the influent. Those devices should be located at the outlet of the fixture. Flow control devices also have air intakes, which allow air to be drawn into the device to promote flow. Grease interceptors must be vented. Grease interceptors are limited to flow rates of not less than 20 GPM gallons per minute and not more than 55 gallons per minute. Here again, plumbing codes set the criteria. Food, waste, garbage disposal are not to be connected to grease interceptors. There's one more page here. Let's just get through this. There are 4 designs in a grease interceptor currently being used. Those designs are manual, semi-automatic, and automatic and enzymatic. Manually operated units are designed to have the grease physically removed from the surface. Semi-automatic units allow the grease to be warmed and drawn off the interceptor. Automatic units electrically skim the grease and direct it into the separate tank chamber. Enzymatic units are permitted convert grease into liquid and water soluble compound by the injection of enzymes. Grease disposal is the #1 problem for those contractors who deal with grease for a living. The number of municipal wastewater plants which will accept grease is rapidly declining. Landfills will no longer accept the disposal of grease at rendering plants is the wave of the future. When dealing with any type of interceptor, be aware the principle with which it operates, understand the design, troubleshooting then becomes easier. Then and only then can you deal with an interceptor in the most professional manner. A professional technician does his job efficiently and effectively. So they only allow certain fixtures. We're just gonna stick to just grease side of interceptors here. So I'm gonna break this off real quick, and I want you guys to go over what passes. I mean, what would pass through if you're in a commercial kitchen? What passes through the grease trap before it enters the sewer system? So I'll have you guys discuss that, and we'll come back. We'll go over it. So, what fixtures in the kitchen, commercial kitchen, pass through the grease trap before it is sent into the sewer system? So go ahead and join a room. I don't know what's happening on my side, but All right, we got everybody back. I don't know why that does to me on breakout rooms.
Gotta change your settings.
Ah,
You gotta go online though to change the settings of the breakout room.
oh, okay. All right, so
I have a real quick question, Josh.
okay.
You know, a lot of us back in the day, we kind of all remember putting dishwashers to the grease interceptor, and I guess we don't do that anymore. Is that can you find out if that's like a jurisdiction thing, or is that new UPC, or what is that? Where's that come from?
So I see Mr. Allen in our group. I mean, I can kind of answer that question, but if Steve, are you here, Steve? Steve always has the better answer. I don't hear him. But anyways, no, the dishwashers here on Maui were taken off being installed on the grease line. I think in Oahu, we talked about this earlier, about Oahu still is allowing grease traps to be tied in on the grease line. I'm hearing something in the background.
Hey, Josh, we just went to Jack in the Box in Pro City, and their dishwasher was actually, yeah, it was tied into their sewer system.
Yeah, when we were talking to Darren after that one class, we were asking questions about the dishwasher still being on the grease line. Is that they were still allowing it there?
That's a choice.
Yeah, but on Maui they restricted it here, that, you know, because what happens when you know, a commercial dishwasher is pouring into the grease strand, what happens is it's liquefying the grease as it enters the trap. And
That
you know,
makes sense.
yeah.
Hey, Josh.
There's Steve Allen.
Hey, I don't know what the hell. I couldn't have my glasses. I couldn't see what the hell I was doing. All right, so I'll give you guys the answer that the old guru knows. And it's going to be political. First off, Maui County did it on their own because they're a bunch of monkeys and they followed this program from this old Portuguese guy here that thought he was brilliant. So let's do simple math, which I'm not going to expect anybody to do the calculation here. So we got grease traps anywhere from 250 gallons, 100 gallons, but our maximum capacity is 1,500 gallons on Maui, 2,000 gallons on Oahu. Does anybody have an even idea of what the discharge is on a dishwasher? Commercial dishwasher average? Just throw a number out there.
Dump 5 gallons?
Yeah, if you said 5 gallons, you'd be heavy. If you said 10 gallons, you'd be, I don't give a shit if you say 20. Because here's the reality. What do you think 10 gallons of water, even 20 is going to do to a 1,500 gallon grease trap and temperature wise? Like nothing. So I always argued, I went to the council on this thing. I mean, I said, you guys are full of crap here, but they wanted to be the power broker, so they kept their rules. But to me, it's the dumbest thing in the world. I think a dishwasher should go to the grease trap. And here's the reason. 50% of your grease is on the damn plates. So they make these guys spend all this money to put the grease traps in, and then they let 50% of the grease go down in the waste system. So, you know, to me, it's ignorant. Now, here's another story on ignorance. So with me, so a couple of times we went back in and bypassed, went to the grease trap, connected to the dishwasher, and then for some reason they went back and tested them and found it, and we had to pay to correct it. So for me, trying to be smart and right and do the right thing, we got banged a couple of times financially. The answer is you cannot connect the dishwasher in Maui County. You can on Oahu. The reason? Stupidity on Maui. Oahu, smart enough to figure it out. And Maui hasn't corrected it. And the guy that put the rules in, he's long gone.
Huh.
So I guess I should, with an attitude, go in there and tell them to correct it because it's just stupid. Anyway, Justin, that was a good question.
The other, I guess one question too for you, Steve, is they don't allow the hand wash sinks on the grease line also in the in the kitchens also, yeah?
Yeah, on group 5, I don't know what, I couldn't get unmute and I was gonna interrupt before they started talking other stuff, but because I heard that point come up. You know, it's real simple. If you guys think about a grease trap, very, very simple. What and where can the waste system collect grease from? So you got floor sinks, floor drains, rinse compartments, anything that they can get grease on. The reason they got the floor sinks is because they come off of other sinks. The floor drains, because you're washing the floor and there's grease and crap on the floor, and so it can go in there. Hand wash sinks, you know, it's it's really stupid, but oh, well, there's no grease coming from a hand wash sink. So a plumber or the purchaser of the grease trap system or the waste system for a kitchen has to pay for a plumber to run a separate line from those hand wash sink all the way to the waste system, which is just another piece of ignorance. But when it comes to calculations, it doesn't change a thing. So I don't believe that you would get in trouble for running a hand wash sink to it in order to eliminate a bunch of piping. But you know, and we only doing a little bit of that work. Now we just did that kitchen in Lahaina a little bit ago, but most of the time you guys aren't tearing kitchens out and putting new waste lines in. But when it comes to the grease trap, it's pretty simple. Anything that can collect grease needs to go to the grease trap.
Okay. Yeah, you know, the only reason why I bring that up is because, you know, this is our drain cleaning class, is that, you know, when you run into certain commercial kitchens like this, it's good to know what is you're dealing with when you get there. I mean, if you get there and the, you know, for the Maui guys here and, you know, the dishwasher line's backing up, you know, you're not going to run to the grease trap. I mean, some of them are still grandfathered in on the, you know, dishwasher being tied into the grease trap. We still see it today. But even with hand wash sinks, if, you know, floor drains are all backing up, you know, you're not going to go and snake through the hand wash, you know, inlet in the wall, you know, just to stay out of the water and stuff like that, because they're all on separate drains. So hand wash, go ahead, Steve.
Josh, let me interrupt there. That's actually not correct, and I'll tell you why. In the old days, you didn't have to have anything to the grease trap except for the triple compartment sink where you're washing the dishes. And so that's why you went into these old places and they only had that small thing under the sink. And then when they went into this grease management system, the program, they started doing the sizing off that Appendix H and kitchens and meals and lunches and breakfasts and dinners and all that. And that's when large capacity grease traps went in. Now, I missed the beginning of this class, but I want to be real clear about something for all you guys in a grease trap. You know, one, they don't work if they don't have holding time. They have to be able to have time for the fogs, the fats, oils, and greases to be able to separate themselves so the fats float, the water's heavier, it goes to the base, just like oil and gasoline and stuff. So it's all the same principle. But once they started getting, and rightfully so, they needed these grease traps. I mean, they really did. But you guys got to understand, you know, you're going to be in the kitchen business, you're going to be in the food business, and you got to deal with your waste product. You just don't get to take the money from produce and steaks and make money. You got to also deal with your byproduct, and that's fats, oils, and greases, fogs. So when we started getting EPA finding the crap out of the counties and cities for water pollution from sewage overflows, the counties had to do something. That's how this all originated. There was no grandfather dishwashers because they didn't exist. If a guy ran a dishwasher to a grease trap, that's just because somebody did it. But the new waste control kitchen, grease control kitchens only came about, and I'm gonna say 20 years ago. And at that point, Maui County never allowed the dishwasher to go into them from day one. Oahu did. And Oahu allowed 2,000 gallon grease traps, which is just an insane amount of fluid, but that's a whole nother story. So there, if you have a dishwasher backing up and it's suspected to the grease trap, then it's, I'm going to say intelligently tied to it because they should be, but in Maui County, it's an illegal connection.
Yeah, the other thing too is that they don't allow disposals on a grease line, yeah?
Well, you know, they don't have any disposals to a grease line because they don't want the, you know, there's a holding tank situation and you start putting the byproduct of a garbage disposal in there and you start filling it up with the waste real fast. So they have those separators, right? So you scrap traps or trash cans, you know, and that's actually, it's smart, you know. the wastewater department shouldn't have to handle food waste, you know? It's not the same as human waste, and so it should go to the waste, the landfill in that essence. Or it should go to a pig farm. It should go to somewhere where it's recyclable and not just having to be handled by all the pumps and waste treatment plants. You know, don't ever look at this as a bad thing. This stuff's all done intelligently, and just use the intelligence to your selling and application to the owner of the kitchen or the management of the kitchen drain lines.
Yeah. You know, one more thing, when we're looking at these grease traps, you know, we've been in some situations where guys are coming back and telling, you know, restaurants, "Oh, your grease trap is full," when it isn't necessarily full. So we talked about this in our septic classes, is that the water level is below, you know, the inlet pipe to, you know, there's it's always going to be full with water. But if you could still see the inlet to the grease trap, you know, you're not dealing with a full grease trap. A lot of guys see, you know, they open a lid like, oh, thing's full of water. Look around in there and find that bafflety or that inlet pipe coming into that grease trap and see if it's still exposed. Or, you know, sometimes you can still kind of hear a trickle of water coming through, but, you know, don't always claim a grease trap is full without, you know, really looking into it, because, you know,
Josh, let me help you here, because there's really misconception. I'm gonna take you guys to a real case scenario here, and I'm gonna use the word mantle. So Josh has got his arrow there on the water level, and you see a wall, you see baffle, you see inlet, you see exit. So above that, you have the manholes, and you got entrance, and you can look in there and you see a big thick layer of grease, and you tell the guy, hey, this thing is full. Because one, as Josh said, you can see the exit pipe. Now, if the exit pipe is partially blocked by grease and things, which is not a pleasant job and is something we're not doing a lot of, but if you break around the exit on the outlet of that grease trap and you find out that it was just a bunch of grease clogging up there and building a little dam, then you might be all good to go again. But the other side of that is that this drawing kind of makes me think it's a little incorrect. That exit should be below that water line on a mantle, because you see the mantle can be, let's say that grease trap is 1,000-gallon grease trap and it's 5 feet from exit to bottom. You can have a mantle as thick as 2 feet and still be within compliance of when the grease department, or should I say wastewater, says you have to pump it. So if you're going to pump every 3 months or quarterly, or if you're going to pump every month, depending upon your loads, what the grease trap guy is supposed to do and supposed to have the knowledge, and he has a stick and he goes and he pops that mantle, and that's the depth of the mantle, the thickness of the mantle dictates the frequency of pumping. And so we had that happen where, boy, the guy wanted me to pay the pumping bill, and I did. We had one of our technicians go in and say, hey, this thing is full. He just had it pumped a little bit earlier, but there was a skim of grease on it. The guy had to come and pump it again for a couple grand, and he didn't know why he was there pumping it. And he told the guy, I don't know what's wrong with you, why you want to pump this, but here I already pumped it. The guy showed up, he'd already pumped it, so here's your bill. And then he came back to me and said, your guy didn't know what the hell he was talking about. And I said, you're absolutely correct. Sorry about that. So we taught it that day, and we haven't taught it again. Mantles are supposed to be there because that's how a grease trap works. And the thicker the mantle, the more grease they've collected and has not gone into the wastewater system. So just because you see a thickness, a layer in it, doesn't mean it's full. Once again, if it's 5 feet deep, 6 feet deep, and you poke something through there, you'll be able to tell the thickness of that mantle. And you can always encourage the guy to say, hey, you know what? There's a lot of buildup in here. Talk to your grease trap pumper and see where your mantle should be on this thing. I think you're right there at your maximum. That's a safe out. It shows you're knowledgeable, and it ain't your Kuleana, you know? I mean, our job is to make the thing drain. If the exit's clear, the entrance is clear, then it's not draining, that very bottom baffle could be stopped up, which is very seldom going to happen. But you know, that's how you have to have solutions. You have to understand the principle and act and the way they operate.
You know, one other thing also is that when when we're snaking drains in a commercial kitchen like this, it's always good to know where the grease trap is at, because now you know what kind of distance you're dealing with on your snake. You know, if your grease trap is 40 feet away from, you know, the last fixture, you know, you're not going to bury your snake 100 feet in that drain, right? Because you'll end up in that grease trap. So it's always good to know, just figure out your surroundings when jumping into commercial kitchens. Know your distance. Like Steve talked about, the mantle of the, you know, the crust layer of the grease in that grease trap. I think they were saying 30% they can be safe with their grease in that trap. That
That's
mantle
about
can be
correct.
at least 30%.
That's about correct, Josh. So if you had a 5-foot deep one and you're 2 feet deep, you're right there. Yeah.
Yeah, yeah. So they can be 30% at 30% and still be okay. But I mean, you'd
Yeah.
really be able to feel grease if you were poking all the way through it. So again, looking at the inlet and the outlet is one way to kind of gauge, you know, if you're walking into a backed up kitchen, first thing is pop the lid on the grease trap. If you could see the inlet and the outlet, now you know you're not dealing with a full trap. You're probably dealing with, you know, a mainline stoppage before it even gets to the trap. Another scenario is, so I mean, you're gonna snake through a fixture from there. Another scenario is if you do walk up to a full grease trap, you know, we have these sample boxes that are, you know, are the access to clearing or clean outs also. And if you don't know what a sample box is, it's that box at the exit of the grease trap. That it's just like a mini manhole. It's got a little trough drain in it, and that runs through to the sewer system. Steve, do you want to explain the sample box?
Sure. But let's ask Jacob a question.
Yes.
Jacob Apo, that question from Sam. Did you understand what I said earlier? Because Sam asked, did you see what Sam asked in the chat?
Yeah, mantle is the layer of grease on top.
That's correct.
Yeah.
And if you think about a mantle like over the top of a fireplace, that's why they use the word mantle. It's just a buildup over the top, you know. So that yes, Sam, that's what a mantle is.
I was actually just looking that up just to confirm too. I was like, yeah, I think so. Pretty sure.
Yeah, that's what it is. You know, and what were you asking me, Josh?
The sample box.
Oh, okay. Well, listen, you guys, it's pretty simple, but they don't do it. They're supposed to lay a tube in there and catch a flow, and then they send it into a laboratory, and it's a parts per million thing. I used to know right off the top of my head it was 100 parts per million or something, but it might be 100 parts per thousand. But there's supposed to be a level of under fat content or fog that's passing into the city sewer system, county sewer system, municipal sewer system that is acceptable. And if it's beyond that limit, then they got to have better controls on the fog, which means more frequent pumping, or it's undersized, you know, because when they put these things in on Appendix H in your code book, read it. It has very specific sizing guidelines. Now, it's not tough to figure out, and it's not hard math, but those numbers have been proven themselves to work. And the reason is for the sample box and the parts per million. So it should be clean, and you shouldn't see a bunch of junk falling through there. It should be pretty good look, you shouldn't see chunks, let me put it that way.
Yeah. So that is, you know, and that is one way to also be able to diagnose your stoppage. If you pull that manhole at the end of the grease trap and that sample box is full of water, you know, you're not dealing with a full grease trap again. You're dealing with a mainline stoppage past the grease trap. So I know some guys, they like to rip open the grease trap. They say it's full to the rim, you know, over the inlet and the exit, but you know, then they're calling the pump truck guy in again, say, hey, your grease trap's full, just to find out it's backed up past the grease trap. So do your full diagnostics when dealing with commercial kitchens is when you're on site, you see everything backing up. First thing is you go check. Well, first thing is find out what's backing up. You see a floor sink, and then you walk around the rest of the restaurant. You check the other floor sinks. Is anything else holding water? If not, then you're dealing with just that one fixture. If you're walking around this kitchen, everything's backed up. That's when you walk out to the trap. Pull the first manhole on the trap. Look inside. If you see the inlet pipe still exposed above the water, you're dealing with a mainline stoppage before the trap. If you pull that manhole and that water's full to the rim, next step is to go pull the sample box manhole, check if that's full. If that's not full, then now you're dealing with a full grease trap. If the sample box is full, you're dealing with a mainline stoppage past the grease trap. So it's always good to kind of make sure you really dive, because it keeps you from, spinning your wheels and, taking up too much time that doesn't need to be taken on certain jobs. Is kind of know what you're running. I'm just trying to give you guys a quick basics on how to deal with things like this. Otherwise you could be, walking around not knowing what to do, snaking all these drains, and it's not doing nothing. So take the steps in trying to, get through these situations and dealing with these interceptors.
Hey, Josh, let's
Yeah.
point out one more thing here. And you guys in the field, Bennett, you've been around a long time in there. Let's just use the inlet of this interceptor where it says baffle, and you got your vertical pipe, and you got your horizontal, and you got what you can see is like a T. You know what? If you don't see that in there, that grease trap's not working properly. It's not designed properly. It wasn't installed properly. So guess what you need to do? You need to sell the guy a correction. You say, hey, listen, because the diagnostic would be being able to look down that vertical section on that baffle where it's saying, hey, listen, I see water coming in. So you're clear upstream, right? Water's flowing into the interceptor. But you have to have the ability to diagnose properly. And if the interceptors failed, I have seen many interceptors where that T's fallen off. It's not connected. Well, that's a correction. Anytime you see something in there that you can't diagnose and you understand this appearance and how it's supposed to look, then it needs to be corrected. On the lower interceptor, you've got these. Now, this is an interesting older style, and I don't see these very often anymore, but those are gates, and it's level 1, level 2, level 3. If those aren't in there, they won't hold. Guess what? The guy needs a new one. Now, the plastic ones they got now, and on Oahu, you guys got that one high-performing grease trap on the shelf, and there's like 500 gallons. That is modern day wonderful grease trap, and it'll go beyond capacities of the top vertical one, or the top one on this drawing, because they're designed to catch more of and a thicker mantle and separate even faster because of the way they baffle out. But you should always be able to understand this top picture. You have to, like Josh says, you have to be able to diagnose your stoppage. If you can't see into that baffle and that T where you can't diagnose, you got a problem to begin with. It needs correction. If there's any of the things in here where you cannot do the diagnostic, get a book, show the owner, this is how it's supposed to be, it needs correction. They need to coordinate a pump truck. You need to get, when the fluid's out of there, you need to get in there and correct the problem. It's nasty, rotten work, but sometimes that's what we do, nasty, rotten plumbing.
All right.
How many of you guys have seen someone, like you come in after someone who's knocked the inlet baffle off, like cabling down or whatever, and just sometimes they don't even glue it for some reason. Interesting.
And it's absolutely right, Justin, absolutely correct. So this is the key, though, to understand how it's supposed to be. So when you get there and it's not, say, hey, man, we're wrong here to begin with. It's not your fault they don't make a correction, but it's sure not our fault that we can't diagnose properly when things are broken.
All right. We can continue a little more on our next meeting together next Tuesday. We are almost at 8 o'clock, but thank you, Steve, for being here today and blessing us with your knowledge.
Oh yeah. Well, I got
And,
I got something for Jeff here before we go then.
Okay.
So Jeff, the other day, he wanted when he came up, drop something off, he wanted a quote. So Jeff, here's your quote for today. Excellence is not an accident. It's an attitude.
Steve, that hit the spot. Thank you.
Okay. All right. We'll see you guys.
All right.
All
Thank
right.
you, Steve. Thank you, guys. You guys have a good day, and we will see you on Thursday for Connie's meeting.
Thanks,
Thank
guys.
you.
Josh, thank you, Steve.
Yeah. Thank
Thanks,
you, guys.
everyone.
Dude.
All right.